Hello, welcome to this session. In this session, we are going to see using a light dependent resistor. So, we'll start by opening QUCS. Now, here we'll open a new project. We'll click new and we will type LDR. LDR stands for light dependent resistor. So, we create our project. So, we have come to the blank untitled screen, untitled file. So we'll go to the component library and we'll select a resistor, rotate it and position it in the screen, and we'll set a second resistor. Now I will now change this. R2 is going to be my light dependent resistor. So in QUCS you do not have a circuit symbol for light dependent resistor. So we will change R2 to the name. We'll change the name of R2 as LDR, and we will change the value for R as we'll change it as RL, so that this resistor's resistance depends on the intensity of light that falls on this resistor. Right. Now to complete the circuit representation, I use insert equation. So I will insert an equation here. So default it will have y equal to 1. I'll double click it to change the equation. So my RL, I will type in the right hand side will be the term or the parameter which I am going to define, and in the left side I am going to give the equation. So this I will keep it as 500,000 divided by LUX. So lux is the luminance per meter square of, and this is the measure of light. So brighter the light, lesser the resistance. Lesser the light, more the resistance. So we have set an equation for this LDR. Now we'll complete the circuit by using a DC source. So we'll select a DC source, position it somewhere here, escape the command. I'll set the value at 5 volts, and then I am going to add the ground symbol. So I will go and select the ground symbol. I'll bring one ground symbol here, one ground symbol, I'll keep it here. I will move this DC source until it snaps to the grid. Now I'm going to connect wires. I am using Ctrl E on the keyboard to bring in the wire command. So I click at one connection point and then click again at the next connection point. I click, drag, and if I want to change the direction, I have to just right click. The direction has changed, and I click at the connection point. So this is just to remind you about using the connection command of this wire command of QUCS. So we have completed the wiring. Now I need to measure the voltage at this point. So I will use a name for this wire. I will click wire label command. I will click wire label command. This is wire label command. Keyboard shortcut is Control L, and now I will click on the wire. I will call this A and click OK. So things have been settled. Now it's time for us to run this simulation. So I will select the simulation. I will have a DC simulation, and before that I'll change R1 to, let us say, at least 1K, and then we need a parameter sweep, so I will select this parameter sweep and bring it here. Now I open this parameter sweep simulation. It is going to do simulation on the DC circuit, and I am going to sweep the lux value, and lux value I am going to change it from, I'll start from, let us say, about 200, which is going to be the let us say almost dark, and 25,000 is going to be the daylight, and I will use a number of uh, experiments. So I will have values of around 20,000, or let us say I will keep it at 5,000, 5001, and I'll click apply and click OK. Now I am going to run simulation. Either I can click on this button or click F2 on the keyboard, like this. So I have to save the file. I will call this LDR basics or LDR intro, and save it. So now I will use a Cartesian. So I am going to select AV. So this is the output you get. So obviously, brighter the light, you have a curve like this. So as the daylight keeps on increasing, or the light intensity of the light that falls on the LDR increases, the resistance will come down, and so the voltage will also come down. So now we'll come back again to this circuit. What we'll do is we will add some more circuits here so that we understand how this thing works. So we will select this entire thing, the entire circuit, that is R1 and LDR, and now before that I'll change this LDR as LDR1, and then select these two components uh, along with its wire label, Control C to create a copy, and then Control V. We'll just bring it down. Can use the cursor button to move them. Now I will change this to B, and then complete the connection. Now I run simulation again. Now I come here and select BV also, that is voltage at O connection B. So they are overlapping. Oh yes, we forgot to change the value of this. So I'll change this and I'll keep it 2.2K. Now run F2 again. So now you see, higher the resistance you add with this, sharper the voltage fall. So, so you can decide on how fast you want the circuit to vary with respect to light. So you see the sharp, it is very sharp for 2.2K. You can change, you can make one more copy of this circuit. You can pull it down to position it at the same height of the other circuits. Control E again to connect them, and then change the wire level to from B to C. Now you can again simulate the whole thing. You can change this, change the position of this equation. Instead of 2.2K, I will have 3.3K and run F2 again. I need C to come here, so I double click this graph and select C also. Now I have got three different. Yes, now the change is less as you keep on increasing your resistance. So still you can always, if you want to increase the grid lines of your graph, all you do is you double click this, go to the properties, go to the limits, and now on the x-axis you turn on the limits, the manual, and so you can change the step limit to 500. Same way in the left axis you can change the limit to say 0.1. Now we'll apply this. Now you see the graph is having a lot of grids. When you find it weird, you can change it. You can always go back, go to limits. I'll keep it at 1000 and I'll keep this at 0.5. Now we'll okay, you can enlarge the grid. So you see now you can see where you want the whole thing to switch off. So this is our voltage. So you see you will probably switch a transistor at around 0.67 volts. So you want the uh, circuit to switch on at a lesser light, you choose a higher resistance. Okay, you allow, if you want it to switch on when the lux is around around 400 lux, then you will have to choose a 1 kilo ohm resistor. So like this you can choose the resistance value to suit the to suit the sensitivity of your circuit. Now we go a step further. We are going to use this circuit in a switching circuit. So I will go back to the content, save all my files, go to project, and again come back to content. When I do this, I can close this. I go to project and again select my LDR, and you see that LDR intro is available here. Now I have another untitled schematic page in this project. So the project name is available here. Now I again go to components. I start with a resistor. I will set the value of this resistor at 2.2k, and then I'll bring one more resistor here. This is going to be my LDR. So I will change its name to LDR and change the value to RL. Then I go ahead to add a DC source. Now I add ground. I am using Control G to bring the ground symbol. So I position them. Now I'll just position them like this. Now I'll use Control E to start the wire command. Click at one connection point, move down. If I want to change the direction, just right click on the mouse button and then click at the connection point. The command is finished. Now you go to create the next wire. You click, drag, and then click, drag, and click. So we have completed this. Now we'll complete this by writing our equation. You can keep your equation anywhere. You can keep it outside the area where you are going to have this circuit. So you can drag it somewhere here like this. It doesn't matter where you position this equation. So I double click this. So it is, I'm going to declare RL as the variable and the function is going to be, I'll keep it at 500,000 divided by LUX. So lux is the variable which I am going to use in this circuit. Now I will change the voltage to 5 volts. Now if I am going to use this as in a switching circuit, obviously I will need a transistor. So I will go to the libraries. I will open transistors and I will choose a transistor. So you people used BC107 in your lab, so I will use this BC107. I can go to the manage libraries and see what BC107 characteristics are. So I will now select the transistors, and in the transistors I will go down to BC107. You can select here and type B. You will come down to try to names that start with B. So BC107. So it shows the details about this transistor. It is having a, so you can see the PSpice model by clicking show. So this is the PSpice model of this transistor. So if this transistor is not a discrete component, you can even have the VHDL and Verilog PSpice, which you can use in your IC design in VLSI. So this is my transistor. So the basic parameters are this transistor is having a 300 milliwatt maximum power dissipation, maximum collector to emitter voltage is 50, and maximum collector current is 100 milliamps. It has got a TO18 metal case. Now I will drag this. I just drag this and then escaping. I need, now I'll position this. I'll select it, drag it like this. I'll keep it like this. Okay. I will drag this LDR, my R2 and its associated circuit a little bit down so that we are able to connect this. So I am just positioning the components so that they are at comfortable distance, right? So it's purely on the schematic. It doesn't really depend on the distance of these actual devices. So this is purely for convenience in drawing. Now I select this R1, make a copy by using Ctrl C, and then paste using Ctrl B and position it somewhere. So this is going to be my load for the transistor. So the transistor is in common emitter configuration. I'll complete it by wiring. Now the base signal comes from the junction between the LDR and my thing. So I'll change this R2 as LDR1. Right? Now I have got to give a ground signal for the emitter. So I'll bring a ground signal, position it somewhere here, and then Control E to start the wire command. Click, drag and click. Now we have completed. Now I will add a wire label. So I will add one label at the base. I will call this A, and one wire label at the collector junction. I will call this C for collector. Okay, we'll change this as base B, right? So now we'll go ahead, go for the simulation. I'll select DC simulation, bring it here, and then I'll have the sweep parameter, bring it here. So whenever I'm going to sweep a parameter variable, I'll use this parameter sweep. So I am going to simulate the DC simulation. I am going to bring the DC simulation here. So I am going to vary this lux Lux I am going to vary it from, let us say, 100 to 25,000. 25,000, and I'm going to have around 10,000 samples like this, and click apply and click OK. So now let us see how this circuit works. We click F2 to start the run the simulation. So this is going to be my light dependent switch. Now we use our Cartesian uh, diagram. We select base voltage as well as collector voltage. Now we see how the whole thing. So you see, the red one is your collector switch. So you're switching like this. So just when you can select this, go to the limits, you go to the x-axis. Instead of a step of 5,000, you have a 1,000, and click OK, and so if the scale is very crowded, let's go back and set it at, let us say, at 2000. So it is switching on when your light is, let us say, at the evening level. So at 5 o'clock your switch will turn on. So you can use this circuit to turn on something that, say, turn on a light when it is dark, or you can turn on an operation when you, let us say, it will turn on the security light when the door has been closed. So you can use this circuit for to respond to the variation in light. Now this becomes a light dependent circuit. So you are now measuring the voltage at the collector junction. Then you are going to take the signal from the collector to other circuits. But supposing you are going to run a relay in the collector circuit itself, then then we going to measure the resistance, the voltage across the resistance. So I will now measure the voltage across the resistance. So if this so this is this we'll use this approach whenever we are going to add a load to the collector circuit. Now we run PSpice again. Now here I will select PR1E V and click apply and click OK. So now the pink line is the switching circuit, the voltage level in the resistor, while the red one is the voltage level that you get at the collector junction. So you can either use the circuit as a switching amplifier for other circuits, or your R1, your R3 itself can be a load. It can be a motor, it can be a light, it can be a relay, and then then your circuit, so there will be a current through the resistor when there is light, and there will not be any current when the resistor is when there is no light. So if you want to change the situation, all you have to do is just change the position of the devices. I select this. I will just control C and then remove this. Now I use control V and bring it here. Copy and then control V. So I brought back this LDR there. Now I'll select R. I'll select R3, control C and then control V. So I just change the position of these switches, of these sensors, the light dependent resistor and its current limiting resistor. Now we run F2 again. Now you see the entire circuit's switching characteristics have changed. So this is the switching characteristic of your. We'll have to increase the value of this resistor. We'll keep it at 10K. We still don't have any change, so we'll change it to less than that. We'll change it to, let us say, 100 ohms. So now you see you are getting the switch. So now what happens? Your resistance load, that is R3, there will be voltage across R3 when there will be no light. So the pink one is our is the voltage through the resistance. This is the voltage through the resistance. So it will turn off when there is light, as long as it is, sorry, it will turn on when there is light and it will turn off when there is no light, while while the output at the collector base will turn on when there is no light. So yes, it will turn off when there is no light and it will turn on when there is light. So this is how the circuit will behave. So if you want the load to be turned on when there is in daylight, then you use it like this. But if you want it to turn on when there is darkness, then we just change the position of the LDR in the sensing circuit. So this is how you use a light dependent resistor. I hope you enjoyed this session. We'll meet again in the next session with some other application. Thank you.